All right, hello everyone. We're going to talk about Gay-Lussac's law first today. So let's look at the first guided practice problem right here on your paper. It says, determine the pressure when a constant volume of gas at 3 atmospheres is heated from 22 degrees Celsius to 83 degrees Celsius. So we see a changing set of conditions for a gas, and so we know that we're going to start with this combined gas law from your periodic table. Now, the one on your periodic table has P, V, and T. Remember, we add an N for amount of moles to the denominator as well. So the combined gas law from the periodic table basically is P1V1 over N1T1 equals P2V2 over N2T2. Remember, this is pressure, volume, number of moles, and temperature for the way it starts and the way it finishes. Okay, in this problem, it says we've got a constant volume. So if that's constant, we can change that on both sides. Of a gas at 3 atmospheres is heated from 22 degrees to 83 degrees. So it looks like our temperature is changing, and then it asks us for the new pressure. So our pressure is changing, but it doesn't say anything about the number of moles changing, so we can cancel that out as well. So when the only things that are changing are pressure and temperature, we get the equation P1 over T1 equals P2 over T2. We don't need these other variables because the volumes cancel each other out because they're the same on both sides. The number of moles cancels each other out because it's the same on both sides. And this is what you should write down right here as Gay-Lussac's law. But as you see, it comes directly from the combined gas law in your periodic table. Okay, so now let's go ahead and solve this problem. We have, our conditions from the problem. It tells us the initial pressure is 3 atmospheres. It asks us for the new pressure, so P2 equals question mark. It tells us the initial temperature equals 22.0 degrees Celsius, and the second temperature equals 83.0 degrees Celsius. Remember that for all of these variables, we just have to have the units match, but it doesn't matter what the units are except temperature. Temperature has to be in Kelvin for that equation to work. So we have to change those Celsius into Kelvin. How are we going to do that? Remember, you have this formula on your periodic table that says Kelvin equals degrees Celsius plus 273.15. So basically, I'm just adding 273.15 to both of my Celsius temperatures to get the Kelvin temperature. So this one is going to be 295.15 Kelvin when I add that to it. And this one is going to be, check my calculations from before, 356.15 Kelvin. Okay, now we can go ahead and plug in our numbers. So P1 is 3 atmospheres over T1 is 295.15 Kelvin. And then I don't know what P2 is, but I know that T2 is 356.15 Kelvin. I'm going to solve this using cross products. So 3 times 356.15 is equal to, and notice that I just got rid of the units. I know that the units of this are going to be atmospheres because they're that over here, so I'm just going to get rid of the units for the actual calculations part. So this cross product equals this cross product, so P2 times 295.15 Kelvin. Okay, so I'm going to multiply these numbers together and then divide by this number. And then the P2 that I get when I do that is 3.62 is what my calculator gives me. But look at the numbers that they gave us to start with. 3 sig figs, 3 sig figs, oh, only 1 sig fig. I mean, that's our limiting given in the number of sig figs. And so we have to round that to 1 sig fig, just like this one has. So this would be 4 ATM is P2. Okay. All right, let's go ahead and look at problem number 2. Okay, problem number 2. A gas is compressed from 72 kPa to 750 millimeters of mercury. So compressed means the container is made smaller and the pressure goes up. What's the final temperature if the gas was originally at 48 degrees Celsius? Okay, so I take that back. I'm sorry. Normally, compression involves volume change, but in this case, there's no volume change. See how it doesn't mention any volume change? And so we're only changing pressure and temperature. So they're actually changing the pressure inside by changing the temperature. All right, so with any of these where we've got two sets of conditions, we're going to go back to our our combined gas law. So we have P1V1 over N1T1 equals P2V2 over N2T2. In my problem, it says a gas is compressed from 72 kPa to 750 millimeters mercury. So I've got a P1 and a P2 at 72 kPa and 750 millimeters mercury. And then it says, what is the final temperature? So I know I'm going to have a T2 if the gas was originally at 48 degrees Celsius. So T1 is 48 degrees Celsius. Now I know this temperature has to be in Kelvin, so I'm going to use my formula from before, add 273.15 to my Celsius temperature to get the Kelvin temperature. Remember, that comes from this formula. Okay, so when I do that, I get 321.15 Kelvin. Okay, now notice that my pressures are in different units. It doesn't matter what unit I put my pressures in, but they have to match. So this unit has to match this unit. So I could either switch them both to millimeters mercury or both to kPa. I'm just going to go ahead and switch this one to millimeters mercury. So I want to make my conversion factor where I put kPa on the bottom so that it will cancel this out. And I'm going to put millimeters mercury on the top because I want to have the same unit as over here. And then I'm going to go back to this place on my periodic table where it tells me how many kilopascals are equal to a millimeter or equal to how many millimeters mercury, because for a conversion factor, remember, those two have to be equivalent amounts. So it says 101.325 kPa and then 760 millimeters mercury are equivalent amounts. Okay, when I calculate that, getting squeezed here, when I calculate that, I get 540 millimeters mercury. Okay. All right, so now we've got our units matching. We've got this guy in Kelvin. We can now go ahead and plug in. We started with this combined gas law, but we just are using pressure and temperature, so volume is staying the same, which means I can cancel it out. Number of moles is staying the same, which means I can cancel it out. And so I'm just going to have P1 over T1 equals P2 over T2. Remember, that is Gay-Lussac's law. And now I'll plug in. So I have 540 millimeters mercury over 321.15 Kelvin equals 750 millimeters mercury over T2. All right, I'm going to solve it with cross products. So 750 times 321.15 equals T2 times 540. Divide both sides by 540 to get that variable by itself. When I do that on my calculator, I get T2 equals 445.8. So let's check how many sig figs I can have. 2 sig figs in this given, 2 sig figs in this given, 2 sig figs in this given. I need to round it to 2 sig figs. So I'm going to round it. I get to keep numbers, non-zero numbers there and there. The 5 makes that round up to a 5. So this will be 450 kelvins is T2. All right. I want you to try number 3 and number 4 on your own, and there's a key that you can check as you do that. Just a note on number 3. Notice that well, I'll tell you that there's going to be some information in here that you don't use. Okay, let's look through this problem together, and I'm not going to do it, I'll let you do it. It says, imagine you have an empty soda bottle that is glued shut. There's air trapped inside. The gas pressure is 1 atmosphere, the gas temperature is 20 degrees Celsius, and the volume of the gas is 200 milliliters. You place the syringe in the freezer and the gas pressure decreases, let's underline that, gas pressure decreases to 228 millimeters mercury. What is the temperature of the freezer? Okay, so what is the temperature? So it gave me all this information, but the only things that are changing are the pressure, because it gives me another pressure right here and it tells me that the pressure decreases, and the temperature, because it asks me for the new temperature. So don't let that other information fool you. I don't need to know the volume because it's not changing, so I don't have to use that. And that's the only piece of information it gives me that I don't need. Okay, so here are my initial conditions. There's my initial pressure, my initial temperature, my new pressure, and it asks me for my new temperature. Notice that those pressures are in different units, so you're going to have to change one of them to be in the same units as the other. That temperature is in Celsius, so you're going to have to change it to Kelvin. Okay? Again, key is posted. Try that one and then check your work with the key.